What's going on, everybody out there in the world? It's your boy Jay Veal, CEO of INC Tutoring, ready to continue on for rational expressions, multiplying and dividing rational expressions. Now, to recap, we talked about last time about what a rational expression was, and also how to actually, perform the operations of just a general rational expression where we divided two different expressions on the top and bottom of the numerator and denominator. We discussed that ratio from the root word, or rational from the root word was ratio, which means a fraction basically. Now we're going to expand our thinking a little bit to another type of problem. It's a little bit more advanced, not much, and I also want to know what makes our fraction, our rational expression rather, undefined in this problem. So, come on, walk with me for this journey, all right? Here we go. As you can see, first problem we have 5x, excuse me, 5x times x squared plus 4x plus 3 divided by x minus 6 and x squared minus 9. The first thing you're probably asking yourself is, how in the world am I going to break this down? It's not that hard, all right? Those out there that think that math is hard, it's really not hard. You just got to think, relax. I got your back, all right? Here we go. We got to factor x squared plus 4x plus 3 first. Then we got to factor x squared minus 9. Here's how we're going to do it. Remember in the last video we talked about getting the common factors of the first term and the third term. We know the factors of 1 are 1 and 1. The factors of 3 are 1 and 3. What are we trying to get, folks? 4, right? In the middle term, right here. We're trying to get 4x. We have to, by any means necessary, we got to get the 4x, right? So in order to do that, we know 1 times 3 here, or 3 times 1 here is 3. 1 times 1 here is 1. 3 plus 1 is 4. Okay? Good. Now, pause, break for a second. Let's see what the numerator equals then. We got to set up our binomials. We know x squared has to go first, so x goes here and x goes there. Remember we talked about a minus and a plus last time. We need a minus and a minus to get to a positive, or I'm sorry, a minus and a plus situation in the binomials. However, we got a plus and a plus here. So to negate that fact, we need a plus and a plus in our answer choice. All right, so here we're going to plug in a plus, plus and plus. We already have 1 and 1 represented with the x on the coefficient. So now we need a 1, I'm sorry, a 1 and a 3. So let's do that. X plus 1, x plus 3. When we FOIL this, it'll be x squared plus 3x plus 1x, which is 4, plus 3. We are solid, folks. We're solid. Okay? Does anybody not understand where we're at so far? Let me know. Alright, cool. So now, if you needed to pause the video, you can do that to catch up or take notes. Let me do the denominator real quick. So, here we leave x minus 6 alone. We can't do nothing with it. But here is what we call the difference of a perfect square. Difference of a perfect square. Now we have something like that. It means that there's going to be a setup with a minus and a plus in it with the binomial. Watch what I do real quick. So on this side, it'll be x minus something and x plus something. In this case, so 9, the square root of 9 is what? It's 3. The square of 3 is what? It's 9, right? So, the difference of a perfect square means I can take the square root of this term here. Square root of 9 is 3. So we get a plus 3 and a minus 3 for this. So when we FOIL, we get x squared plus 3x minus 3x, then minus 9. The very important thing in a difference of a perfect square is there will not be a middle term. Like the trinomial, we get a binomial situation right here where we don't have a middle term. First term, second term. All right, cool. Let's simplify, okay? Our simplification step. What can cancel out? What can cancel out here? X plus 1? Nah, can't do that. X minus 6? Not the right answer. X minus 3? Nothing in common with x minus 3. But x plus 3, how many do I see? I see one upstairs, I see one downstairs, right? So here we go. Let's cancel them boys out. Boom, boom. Drop it like it's hot real quick on x plus 1. We drop it down. X plus 1 is left over x minus 6 and x minus 3. Okay? Now, is this our final answer? Can we reduce this to any more terms? The answer is no, we can't. Okay? X plus 1 is its own factor, x minus 6 is its own factor, and x minus 3 is its own factor, folks. We are done. It is that simple to knock this out. Okay? This is algebra 2 and dividing and multiplying rational expressions. Very simple. Okay? Let me box this up for you as your answer. Check, it's correct. We'll move on to some more examples. Great seeing you. Glad you came to visit again. It's your boy, CEO of INC, Jay Veal. Thank you. I'll see you next time.